So we have already covered the theory part of inheritance, and this is going to be a demo section. So we will start writing some code on the inheritance, and in subsequent tutorials we will try to run these classes. So for now, let's start. So here on the left hand side we have basically the UML diagram of our use case of the sample inheritance hierarchy that we discussed in the theory lecture. So we have a class message sender, and this class has two methods, send and format message. Then we have several classes, child classes, and these classes are inheriting the message sender class with some custom implementation. So for example, multimedia message sender is overriding format message, but it will be using the default send implementation. Similarly, email message sender is the child, but it will be overriding send method, and it will be using the default implementation or the parents implementation of format message. But video message sender is a child which will be overriding both the methods send and format message. And on the right hand side in the IntelliJ, we have the parent class message sender. It has two methods, send, which is simply printing the name of the class to distinguish which version is it on the console, and some message that says sending. Similarly, in the format message, name of the class and formatting text. So we have our parent ready. Now we have to create the child classes. So we will see how to create child classes in Java based on this one. So let's create our first child, which is multimedia message sender. Multimedia message sender. Now we need to do something to tell JVM that this class is extending some other class. So we do that via extends keyword. So we will write extends and then the parent, which is message sender. And here we are saying that this child has to override the format message, but because it will be using the default implementation or the parents implementation of send method, so we don't need to write send method. We will simply override the format message. So let me define the format message method in the child and sys out name of the class and a message formatting, let's say multimedia message. So this is our first child class, multimedia message sender. We will cover the rules of overriding in later videos, but for now, I think you can consider this method implementation to be an example of overriding. Okay. Moving on, let's create a second child class, which is email message sender. Again, extends keyword, name of the parent class, which is message sender, and in this class we are going to override the send method. So we only need to give the implementation of send. A println statement, a print statement, basically name of the class, and sending email, a message to differentiate the child version from the parent version. So we have two children's ready. Now we move on to the third class, which is video message sender. So let's add that one as well. Video message sender is extending message sender. At this time, we have to provide an implementation of both the methods, because as per our design, we are saying that video message sender will override both the methods send and format message. So let's do that. Public void send print statement, name of the class, and sending video. Similarly, public void format message, another print statement, name of the class, and formatting videos. So we have the hierarchy ready. We have the parent class, then we have all three children, extending the parent, overriding the corresponding methods. And in the next video, we will try to run this code. We will try to instantiate child objects and we will see how to run this inheritance code. That's it for now. Thank you. See you in the next lecture. Now that we have set up everything, we have the parent and the children ready. In this video, we will create few objects and we will see how inheritance behave. So in order to do that, let me add a new class that will have the main method so that we can trigger everything. So I will create a new class with main method instead of reusing the existing one. So let me name it inheritance runner and let's add a main method. Now, what are the options? So the option number one is if we start from the parent, which is basically the message sender. So we know that there are two methods in the message sender class. So the option number one is we simply instantiate or we try to create a new object of parent. Let's name it parent and we say new message sender. So we are saying that we want to create a new object of message sender. The left side represents a reference of message sender class and the right hand side represents that we are calling the message sender constructor. So we are basically creating a new object of message sender. Now if we try to call methods on this object or this reference variable, first let's call format message and then dot send. So we'll see which version is it. Okay, and let's also print a separator. So if we run the main method, we see this is calling basically the message sender version, formatting text, and then message sender sending. So there is no inheritance in play. It is the vanilla version of running a Java class that we have been doing. So there is no inheritance, there is no parent or child. So let's pick one of the children and let's see how does it change basically. So let's start this class. The first child, which is extending message sender, and it is overriding only the format message. So when we call the format message, it should print this message using multimedia message sender. But if we call send method, it should actually use the parent's version of the send. So let's see. Let's create the object of multimedia message senders and name it child1. New multimedia message sender. And now if we call format message and send, and if we run it, then we should see uh, inheritance, some inheritance play actually. So before we do that, please note that this child is only overriding format message. There is no send implementation here. So it should call the parent's version of send. Okay, let's run the main method again. And this time we see this is basically this remains the same, this part, but here we see the format message because here we are creating the object of multimedia message sender. On the right hand side we are calling the constructor of multimedia message sender, so we will have an object of multimedia message sender which is a child of message sender. So if we go to the format message, we see the custom implementation because the child has overridden this particular method. So we see that it says multimedia message sender and formatting multimedia message. But on the send invocation, it goes to the parent and that's why we see the message sender sending. So the method that we have not overridden, it will call the parent's version of that method, but the method that we have overridden, if we have written some custom implementation, then it will call that version of the method. So we see here the child's version of format message. Let's try one more example, and this time we will try something different. So we say that message sender, and let's name it child2, and let's call video message sender, or maybe email message sender. Let's pick email message sender for now. Now on child2, first we will call format message, then send. It should be child2. Now what should happen? Because on the left hand side, the reference is pointing to message sender, which is parent, but on the right hand side, we are calling the constructor of email message sender. And if we go to the email message sender, we see that there is no format message. It is not overriding the format message, but it is overriding send method. So what should happen when we are calling format message or any method that is not there in the child class, if we are creating an object in this way? So let's see if we run it. In the last block, we see that it is actually calling the parent's version of format message, because email sender does not have the format message. It is only overriding the send method. For the send method invocation, we see that it is correctly calling the child's version, which is basically email message sender and sending email. So we see that there is no difference. In these two calls, there is no difference. Either we create the object of child via the same class name, or if we create the child's instance using the reference variable of parent, there is no difference. And we learned about it that what method can be called on the reference variable is decided by the type that is on the left hand side. So in the message sender, because we have both the methods, so these two calls are fine. We can call format message and send on child2, because child2 is referring to message sender and message sender has both the objects. So this is fine. What method will actually be called on the runtime is decided by the actual object. So on the right hand side, we see the actual object is email message sender. So on the runtime, when JVM will call the format message and send method, it will be called on the email message sender object. So when we go to the email message sender object, JVM will see that, okay, format message is not there. So it will go to the parent, and that's why we see the message sender. But in case of send, it will see that, okay, email message sender has a custom implementation. So it is overriding there, overriding the method over there. So JVM will simply call the email message sender the child's version of the method. So in this video, we covered different ways to instantiate children and parent, and how can we call basically the overridden version of methods. In the next video, we will cover few more cases related to inheritance. Thank you. In this video, we will talk about the order of constructor invocations. So we know that in case of inheritance, whenever we instantiate the child, the constructor of parent will be called first, then the constructor of child will be called, and then only we will have a working object of the child class. So in this video, we will see this thing in practice, and we will cover some cases, how to do that kind of stuff. So keep things simple. I have this parent class, the empty class as of now, and a child which is extending the parent. And in the main method, I have moved the code in a dummy method and commented it, whatever we did in the last video. And for this video, we are simply creating the object of child. So if we run this class, there is nothing special. We won't see anything on the console because we are not printing anything. But there is no error, so it means everything is working fine. So how do we check that the parent's constructor is being invoked first? So this works fine because we have not provided any constructor, so we are getting actually the default no argument constructor, and the linking is done by the Java compiler. So everything is working fine. But let's see what happens if we start adding constructors on our own. How does it change this linking? How does it impact the order of execution? So let's do that in the child first. Let's say we added a default no argument constructor in the child. That's it. We are not going to do anything else, but that's it. So if we run the same thing, it is working fine. We don't see anything on the console, but it is working fine. We wrote a default no argument constructor same as the default one, and it didn't break anything, so that's a good thing. Now let's do the same in the parent. Run the same thing again. It is working fine. So we know that we didn't break anything, it is allowed. Okay, so how do we know the parent is being invoked first? To do that, let's add some print statements. In the parent version, let's add the parent, and in the child version, let's add the child and run the main method again. And now we see on the console that parent is being printed first and then the child. So we know that when we are creating the object of child, and when JVM reaches here, instead of printing the child, it first checks the inheritance hierarchy. It goes to the parent and it calls the constructor of that parent. And from that constructor, it finds the parent of the parent, and it does that until it reaches the topmost class, which is the object. So in Java universe, object is a class, and this class is the parent of all classes. We will cover the object class in another video, but it does that. JVM does that, and Java compiler also does that. So it checks all the parent classes until it finds the topmost class object, and then it goes backward. Okay, so all the constructors of all the parents will be invoked first, and then only the constructor of our child class will be called, and then only we'll have a working object of the child class that we are creating. So because there is nothing in the object class constructor, we didn't change anything, so we don't see anything related to that. We simply see the message parent on the console and the child that we have printed, but it went up to the object class that we can be sure about. Okay, now how does it do that? So we haven't written anything in the constructor, so how does it know, okay, I have to call this constructor, basically the parents constructor. So of course extends is used to basically establish the inheritance hierarchy. So JDK knows, compiler knows, and runtime knows that these two classes are linked. But there is one more thing we learned about, that one particular thing, and it is this super keyword. So in Java, super is used to access something from the parent. It could be method, it could be the constructor. So there are two ways we can use super, and we will cover both of them for now. Same as the constructor overloading that we covered, and we used this keyword. Same as this keyword, we have another keyword which is super that is used to link the parent constructor. So when we don't define anything, whether it is the no argument constructor provided by the compiler or whether it is the no argument constructor that we wrote earlier or this version of no argument constructor, compiler automatically inserts a call to super constructor or the parents constructor, which looks like this. So this is inserted by default by the compiler, and it's an automatic way. So we don't have to do anything, it will be done automatically by the compiler. So compiler inserts this super class, and that's how runtime knows that it has to go to the parent. And similarly, in the parent, compiler would do something like this. So the runtime will go to its parent, which is basically the object class. And because there is no parent of object, so the call terminates at that point of time, and then it goes backward. So if we don't provide anything, it will be done by the compiler. But we can do this explicitly. In this case, it is redundant. So if we run the same thing again, we won't see any difference. But that is how it's done using super keyword. So for now, let's remove it because it is handled by the compiler automatically. So if we don't provide anything, a super call will be inserted by default. Now, let's say that instead of the no argument constructor, we have a parameterized constructor. So let's change it to something else. Let's add a parameter, any number. Now we see there is a problem. It says there is no default constructor available in parent. And if we run the code now, we will see a compile time error. Actual and formal argument lists differ in length. So super call is inserted by the compiler automatically only if we have not provided any custom constructor and only if classes have default no argument constructor. But as soon as you change something in the parent, then we have to provide a matching super explicitly. So now we have to add the super call to fix the problem. So let's do this. Let's add the super call. But still, it's not fixed. The problem is still there. So let's verify it by running and we see the same problem. So adding the super call didn't fix it. What's missing? The missing piece is that just like this call, a uh, super must have the matching arguments, matching parameters. This is basically a constructor call, but instead of calling the overloaded version of constructor from the same class, we are calling the constructor of the parent. So because the parent has a parameter, it is expecting an argument of type integer. So we have to pass the matching parameter. Otherwise, there is no way we can fix it. So if we pass an integer argument, then we see that it is able to compile and run the class. So we see the parent first and then the child. So we need to remember that in parent, if we have a mix of constructors, then from the child we should call the matching super or the matching constructor. Otherwise, JVM or the JDK will not be able to supply the default super call and it will not compile. All right. So that is all on the super, and there is one more use case of super. We will cover that later. For now, let's stop at the discussion here, and in the next video, we will cover something else on the inheritance. That's it for now. Thank you. So in this video, we will continue a discussion on the order of execution of certain things. We covered the order of constructor execution in the last video, but in this video we will add few more things: static init blocks and instance init blocks. We have already covered these two blocks, but from a single class perspective. How does it behave when we have a combination of parent and child? Parent also has its own instance init blocks or maybe static init blocks, and similarly a child class also has its own init blocks. So here in this example, I have modified parent and child classes with init blocks. So parent has a static init block with some message, an instance init block, and the constructor also has a print statement. Similarly, child has its own init blocks with corresponding messages specific to the child. So what will happen if we run the same program, if we try to create the object of child? We know that static init blocks, they get executed first because JVM calls the static blocks when it tries to load the classes. And we know that even though we are creating the object of child, but because of the constructor linking, the runtime will have to load the parent as well. So the static init block of the parent will get executed, but what would be the order? So let's run the program and let's see what exactly is the order of things. So if we run this program, we see that the parent static init block was first to be called. So before runtime can do anything with the child, it tries to load the parent class, and when the parent class gets loaded, its static block gets a chance to execute its piece of code, its logic, which is basically in this case the print statement. So we see the parent static init block. Then the child will be loaded, the class will be loaded, and at that point of time, the child will get a chance to execute its own static init block. So we see the child static init block. Then comes anything that is related to the object. All right. So because JVM will have to call the constructor of parent due to the constructor invocation thing. So before it can actually complete the uh, constructor of parent, it calls the instance init block of the parent. So we see the parent instance init block, then the constructor gets called. So it prints the message, and at that point of time, the parent call is finished. So the control comes back to the child, and we see that it got a chance to complete the execution of instance init block. So we see child instance init block, and finally the constructor of the child gets a chance to complete it's called whatever is written over there. So we see the child which is being printed from the child constructor, and at that point of time we have an object of the child class. So when we have different set of things, init blocks and constructor, parameterized constructor, superclasses. So this is the order that we need to remember, that first the static blocks of parent and child, then the instance init block and constructor of parent, and at last the init block, instance init block of child and the constructor of child. So that is the order of things. All right, so that's it for this video, and we'll cover something else on inheritance in the next video. Thank you. We know that the concept of inheritance gives us the flexibility of code reuse. So when we are setting up the inheritance hierarchy, a child has a choice. It can use the implementation from the parent, or it can override the implementation. So it has a choice. In case there are different methods defined in the parent class, so a child can, for example, use the default implementation of two methods, but can choose to override the third method or any combination. And we also understand the concept of overriding a method. So for example, here in parent class, we have a method private void log, which simply prints something on the console, logging something. And in the child class, we are overriding the same method log, and it is printing and something else. So we know that the child is overriding the log method, and if we create a new instance of child class and if we call the log method, then we know that this version would be called, and we will see basically and something else on the console. Or if we change the left hand side to parent, then also we know that although log can be called because C is referring to parent and parent has a log method, but the actual method will be that will be called will be this one, because on the right hand side we are creating the object of child. So the actual object will decide the version of method to be called at runtime. So if we run this program, we see and something else, which is perfectly fine by the concept of inheritance. But let's say there is a requirement that whenever we are calling an overridden method, the requirement is to call the parent's version of method as well. So instead of printing and something else on the console, the requirement is that first it should call the parent's log method. So it will print logging something on the console, then its own implementation, so and something else. How can we do that? How can we call a method from the parent in the overridden method? To do that, we will use a new keyword, not exactly new because we have already seen that, but a different flavor of that keyword, which is super. So we know that if we use this particular syntax that is used in the constructor, so if we can use the super keyword to link parent and child constructors, but we can use super keyword to call the methods from the parent as well. To do that, the syntax is a bit different. For example, if from an overridden method, if we have to call the parent's version, so we simply need to write super keyword dot and the method's name. That's it. If we write this code, JDK knows at compile time that okay, this is a call to parent, and parent has a log method because we are overriding the log method. So it must be there. Otherwise, there is no way we can override the method. So that is fine for the compilation perspective. On the runtime, JVM will see that okay, it has to refer the parent and it has to call the parent's version of log method before it can actually execute the child's version of log method. So if we run the same program again, we see that it printed logging something on the console because of the super call, which is basically the method implementation of parent, and then it prints and something else, the overridden implementation. So that is the second use case of super keyword. One is to link the constructor, and the second one is to call the methods from parent. All right, that's it for now. We will cover something else on inheritance in the next video.